Okay, so with 2D motion, all we're going to be doing really is you could think of it almost as like two 1D motion problems and then you're combining them, right? So we'd work individually with like a horizontal vector, like this one right here. We'd find the x naught, we'd find the, or not x naught, we'd find the y naught, we'd find the y, we'd find the initial velocity, we'd find the acceleration, we'd find time, right? We'd get all those variables right in order, right? And then we can solve the problem immediately. But with 2D motion, of course, we'd also need to consider a horizontal vector, right? Like this one. So this one, we'd also find x naught, x, v naught, v, a, t, right? Whatever we need to solve the equation, we'd find those as well. All right, so once we find those individual variables, for both the x and y, then we can solve the problem, right? So it's basically a 1D motion problem, but we just need to spend a bit more prep time to figure out individual things. Now, obviously, some questions will just ask for, oh, well, maybe what's the max height, right? Then that will pertain particularly to just the y, right? But there are other problems where you need both, right? It's just a mix of the two. It's basically, you can think of it as just two 1D problems mashed together, right? In a sense. Now, anyway, with this given problem, it's a bit different since we aren't given any numerical values except for this 45-degree angle. We're also given that this ball is bouncing elastically, which means that it loses no energy after it bounces. Okay, I should also write in this is 45 degrees. Okay, so let's see. First question, what is the velocity of the ball after it bounces? Okay, so when this ball bounces, it's going to follow an arc path like this, right? Since it's bouncing elastically, no energy is lost for as soon as it bounces. There's going to be a small horizontal vector here, right? Because for a short moment, the ball will be traveling exactly horizontally, right? Especially since it's hitting a 45-degree angle ramp. Right. So what that means is that then we can calculate the individual variables for x and y, since there is a horizontal vector here. So we have x naught, or we have y naught, x, y, v naught, v, a, and t. Okay, so we can already fill out some stuff with just the given things we have. So x naught, we can just say it starts at 0. Y, again, we're not given a specific height or starting height, so we can just call this h, right? H. X, we don't know how far it'll go vertically. Here we know that it'll travel h distance down to here. The final position, we can call that just 0. V naught, we don't know it for x, but here, you can imagine we're holding this ball up, right? It's not moving downwards at all, it's just completely still, so we can call V naught 0 as well. But we don't know the velocity for either. Acceleration here would just be gravity for our vertical vector, of course, right? We call that negative g. And then, of course, as we know, in a horizontal vector, for our purposes, there is no acceleration. 0, and of course, we don't know time either. Now, this is the part where elasticity comes into play, because since it loses no energy after it bounces, what that means is that whatever the magnitude of this vector, the horizontal vector, the magnitude of this horizontal vector is going to be the same as this horizontal one, or like the speed, right? Because it loses no energy, right? You'd think like normally if we drive our car through a wall, right, it would slow down considerably, right? But since in this situation, right, after we make contact, we make collision, right, we don't lose any energy, so we don't lose any speed. So that means that the vertical velocity is going to be the same as our horizontal velocity, right? Because we're not losing any energy, right? We're still going to be going the same speed, right? No problems at all. The only thing we'd have to worry about is just that the amount of how the speed changes over time as it travels downwards, right? It's starting at v naught. Right? So what we can do is we can find this vertical velocity, and since we know this is true, or velocity, right? Then we can just say that, oh, well, we found this, so that equals this, and now we can find the variables for x, right? So that's why we're using our y variables to solve for our horizontal velocity, right? Because we don't have enough information just from the x variables to calculate this v naught. Okay, so we can just use the regular equation, otherwise written out as v squared is equal to v naught squared plus 2a times, for our situation, it's going to be y minus y naught, right? So if we plug in our variables here that we have, so it'd be v squared is equal to 0 squared minus 2g times 0 minus h. This will give us vy is equal to the square root of 2gh, right? So we have the square root 2gh. So our x is also the square root of 2gh. Our velocity is constant because there's no acceleration, so we can write this in for both v naught and v. All right, so we have this first part done. We have v naught and v. It's going to be square root of 2gh. Our answer is the first one. Okay, so with the first question complete, we're now moving on to finding the distance that the ball will travel. So whenever you hear the word distance, the main thing that you're going to probably immediately think about are the position equations that we have. So if we put them on the diagram, we'd have y at x, right? So why don't we write down these position equations? So it'd be y is equal to y naught plus v naught t plus a over 2 times t squared, right? So in this situation, things have changed a little bit. So y naught is no longer going to be h, right? Because if you look, right, the distance that we're trying to find is the distance from here to here, right, down at the bottom. It's not up here anymore, right? This was the y naught that we used when we're calculating the velocity, right? But y naught now is just going to be here. So we're not going to have h as y naught. Instead, y naught is actually going to be an unknown, okay? So why don't I put that in magenta just to make it more clear? Right. So you can also say that this height, instead of being y, is just going to be y naught, because we're going to have our y value instead be 0, right? Because if you think about it, right, it goes from y naught to down here. It wouldn't make sense for this to be 0, right? So the distance down here is 0, but the whole like height as to like where it bounces off of from, y naught, that's going to be like the vertical distance, and that's our unknown. Okay. So there is no v naught. V naught is still 0. That remains unchanged. We have, oh, sorry, this one, the addition. We have a negative gravity, so we'd have negative g over 2 times t squared. There you go. That's our first position equation. Just box that real quick. Okay, perfect. Next up, we have x is equal to x naught plus v naught t plus a over t, or sorry, a over 2 times t squared, right? Put everything in. For this equation, since we're still at the origin, right, we don't really have to change anything about the variables. So x is our unknown is equal to 0, or x naught, or actually, we won't even put that in there. Just get rid of this, right? Our acceleration is also 0, so that's not going to be in there. All we have is our v naught times t, which is going to be the square root of 2gh times t. That's our next equation. Okay, so, but we're trying to look for d here, right? And the only variables that we have right now are x and y naught, right? So in order to find d, we're going to need to find some way to incorporate d into this equation, right? Thankfully, we're given that we have a 45-degree angle here. So what we can do is we can use trig functions in order to find a relationship between y naught, x, and d, right? So tangent 45 would be equal to y naught over x. Oh, okay, it's updated for a second. Sine of 45 would be equal to y naught over d. Cosine of 45 would be x over d, right? And then through these equations, we can then put x in terms of d, right? So x, or x and y, not in terms of d, right? So x is equal to cosine 45 times d. I should put that in the front. Y is equal to d times sine 45, right? So now what we can do is we're going to put this this equality in for x. We're going to substitute d cosine 45 for this. We're actually going to solve for t first. All right, once we solve for t, then we can plug everything else into this other position equation in order to find what d is, okay? So we're going to have d cosine 45. Also, I should note, it doesn't really matter which one you plug in for which one. Or this is why not. Right, I just think it'd be easier to plug, to substitute this in for this and then find t that way than to try to substitute this into y naught and try to find t in this equation. So d cosine 45 is equal to root 2gh times t, right? Okay, so then we need to find t. That's what we're looking for right now. So d cosine 45 divided by the square root of 2gh will give us t, right? now we have what our t value is. We're going to put this, as I said earlier, into this other equation up here for our vertical position. So as well as our y naught value into here. So we would get 0 is equal to d cosine, or sorry, not d cosine, d sine or d5 minus g over 2 times d cosine 45 over the square root of 2gh, the quantity squared, right? So we're going to move this over to the other side by adding g over 2 times d cosine 45 divided by the square root of 2gh squared to both sides. So we'd get g over 2 times d cosine 45 divided by the square root of 2gh. That quantity is squared. Let me make that clear. It's a 5. So now we're just going to multiply everything out. Immediately I can see with this square, these two g's are going to cancel out. We're going to have d squared times cosine squared 45 divided by 4 times h. Okay, so the d sine 45. Now we can actually cancel out the d's, right? We can divide d from both sides. And also, sine 45 is equal to the square root of 2 over 2, right? You know that from the unit circle, right? And also, cosine 45, conveniently, also equals the square root of 2 over 2. So that means we can actually cancel out the sine 45 and one of the cosine 45s. So now we have d cosine 45 divided by 4h is equal to 1, right? Because we canceled all this out. Let's go down here for a sec. Now we're going to multiply by 4h. We're just going to isolate the d. So d equal to 4h cosine 45. Cosine 45 equal to root 2 over 2. So you would get yourself d equals 8h over root 2, or otherwise known as 4 root 2 times h. Just make sure that h is not under the radical. There you have it.